So half-life and doubling is kind of like what we did yesterday, except for we don't want to use the formulas to find the equation. We're going to use our calculators to find it. What is half-life? Does anybody know? Yeah, so it's the time that it takes for your substance to decay to half of how much you're starting with. So if you're starting with like 100 milligrams, it's the time it takes to get to 50. Okay, so the time it takes to get to half of where it is. So what we're going to do is make a table and then use that table, plug in our calculator, and that'll give us our equation. So in order to do that, we need at least 2 points. And then we're going to find that equation using stat calc and then the EXP reg. And so remember, that's number 0 on your calculator. Okay. And then we're going to use that equation to estimate whatever we're trying to find, so the needed information. So the first thing that you have to decide in these problems is what is your x values and what are your y values. So your x values are always the independent variables, and so in these problems that's usually time. So x is our time and y is the number of whatever we're talking about. So if we're talking about population, if we're talking about the number of bacteria or whatever, so it is the number of, I don't know, whatever, population, bacteria, etc. So whatever your problem is talking about. Bacteria has a T on it. Alright, let's look at our first one. So this first one says the world population doubles every 35 years. In 1980, the population was 4.5 billion. Assuming the doubling period remains 35 years, estimate the population in the year 2120. So we need a table. So our first point is going to be our initial population. So in 1980, our population was 4.5. So we're assuming 1980 is where we're starting. So we're going to say that's our year 0. And in that year, it was 4.5 billion. So then it tells me that it doubles every 35 years. So 35 years later, what would be the population? 9 billion. Good. So every 35 years, it doubles. So then after 70 years, it would be 18 billion, etc., etc., etc. Okay. Questions on that? Alright, so then we can type these in our calculator. So remember, we go to stat beside our arrows, hit enter, same way that we were doing those graphs at the beginning of the unit. So L1 are our x's, L2 is our y's, and then we go stat calc 0. Should say L1 and L2. And there it is. So at 4.5 and then 1.02 to the x power. Any question on that? Anybody not get that? So now we want to use this to estimate the population in the year 2120. Well, if my initial year was 1980, how many years later is 2120? 140. Good. So I'm going to take 140, which is years, and I'm going to plug it in for my x. So 4.5, 1.02 to the 140. And then you just type that in. So we get 71.98 what? Billion. Good. Very good. Questions on that? Actually, number 2. So number 2 says a bacteria culture triples every 4 hours and starts with 10,000 bacteria. Find the number of bacteria after 30 hours. So first we need to find our equation. So it tells me it triples every 4 hours, but it starts with 10,000. So at hour 0, we've got 10,000 bacteria. But then 4 hours later it triples. So how many do I have after 4 hours? Good, 30,000. And those are our 2 points. So we type them in. So stat, enter. We have 0 and 4, 10,000, 30,000. Then we go stat, calc, 0. And there it is. So y equals 10,000, 1.32 to the x. So then I want to know how many bacteria are in the culture after 30 hours. Where do I plug that 30 in? X, good, because that is our time. And that should give you a super huge number. So 41,420,747. And we are talking about bacteria. So you can say 47 or you can round to 48 either way. And one thing about these problems is if you look at our equation, we rounded our B value, pretty good. It had a whole bunch of decimals. So your answer can vary depending on how you round. Okay? So usually the more decimals, the better. But a lot of times, like if you're checking your paper and your answer is different than mine, we probably just round it differently. So. Any questions on 1 or 2? Alright, so 3 is a little bit different. So 3 says strontium 90 has a half-life of 25 years. So part A, we want to know how long will it take to go from 40 milligrams to 20 milligrams. Well, is 20 half of 40? Yeah, so then that's its half-life, and it told me its half-life was 25 years. So now we want to know how long will it take 40 milligrams to decay to 1.25. Well, in order to do that, I need an equation. So let's do a table. So in this one, we're starting with 40. So year 0, we've got 40 milligrams. And then the half-life is 25 years. So 25 years later, we have half of that. So 20. So those are 2 points. So hopefully, here's your equation. So 40 and then 0.97 to the x. I'm going to say 9727. So I'm going to give 4 decimals. So this one is different because I want to know how long is it going to take to get to 1.25. So what am I going to be solving for in this one? X, because I want to know how long it's going to take. So that 1.25 is my y. Okay. So now this one is like what we did yesterday. So we'll have to get the exponential by itself and change it to log form. And just like yesterday, our first step is we want to divide. So divide by 40. So that gives us 0.03125. And now the exponential is by itself, so we want to change it to log form. Again, if you need to flip-flop the equation to do that, that's perfectly fine. So 0.9727 to the x equals 0.03125. Then we make it a log. And that's what we type in. So log 0.9727, 0.03125. And so we get about 125.2 years. Questions? Alright, let's do one more. Let's look at 4. So number 4 says a cup of coffee contains approximately 96 milligrams of caffeine. When you drink the coffee, the caffeine is absorbed into your bloodstream and it is eventually metabolized by the body. Every 5 hours, the amount of caffeine is reduced by 1/2. How many hours does it take for the amount of caffeine to be reduced to 12? So again, we need an equation. So it tells me when I drink this cup of coffee, I've got 96 milligrams. So when we start off, we've got 96 milligrams. Then it tells me every 5 hours it's reduced by 1/2. So 5 hours later, how much caffeine is there? If it's reduced by 1/2. Yeah, 48. Okay, so there's our 2 equations, or our 2 points. Then we go stat calc 0. And there it is. So now we want to know how many hours does it take for the caffeine to be reduced to 12. So again, we're looking for X. So 12 is our Y. So then again, our first step is divide. And then we change it to a log. Again, if you want to switch that exponential over, you can do that. Either way, you get log of 0.8706 of 0.125 equals X. And then you just type that in. And what do you get? Yeah, so about 15.01, something like that, hours.